I'm not able to get to school to use my smartboard and have my camera and kind of have that set up. So I'm just going to be showing you the computer screen today. Hopefully, you can follow along just as well. We're going to begin in Unit 13 here. We're going to start up Unit 13, and Unit 13 is all talking about graphing inequalities. Just our lesson one here is graphing inequalities and situations. Pretty quick lesson. When we talk about inequalities, inequalities are symbols like this. Okay, that is greater than. So let's say 5 is greater than 2. That's pretty easy. We have one that looks like that. We can say 7 is less than 14. So the symbol is less than. We also have things like this symbol where we have a line underneath. That means or equal to. So x is greater than or equal to 4. And you can also work with less than as well. This lesson, we will know that we have met today's success criteria if I can independently graph inequalities and also situations that go along there. Okay, you should have your notes in front of you. Looks like this to fill them in if that helps you follow along. First off, we know this. X can equal 5. We know that x can equal 5. We've done those kind of problems before in a situation where it's like x plus 2 equals 7. So what's x equal? Well, it equals 5. Well, we can also do this. X is greater than 5. In that situation, any number that is greater than 5 can be x. So 6, 7, 8, 9, 10, a bunch of them. We can represent, instead of writing all of those numbers out, we can represent that on a number line. Here's some of the symbols that you'll see today. Less than, greater than, less than or equal to, or greater than and equal to. Remember, if you pay attention to this word or, it can't be greater than and equal to a number. It has to be one or the other. So let's see that on a line. Let's start our first one here. Caleb has at least $5. The at least is a very important phrase. Let's represent Caleb with a variable. Let's use C for Caleb. Caleb has at least, and we know we're working with $5 here, so put 5 here. So I apologize for the writing. I'm using a mouse today because I don't have my smartboard to write on the board, so forgive the writing. Let's talk about this at least thing. At least means that he's got more than $5, but he could also have $5 as well. He has at least, he could have $6 because that's at least $5. That's $5 plus another dollar. So the at least tells us that Caleb has more than or equal to, so greater than or equal to. That's what that little line there means. And we can represent this inequality on a number line. So let's create that. There's a 0 there, there's a 10 there. Let's count it out. 1, 2, 3, 4, 5 right in the middle. So let's put our 5 there. Again, I apologize for my writing. A little hard to do with the mouse. Okay, let's represent this. So we know that Caleb can have at least $5. So let's put a dot on $5. And he could also have more than that. So Caleb has $5 and then maybe more. So how you do that on a number line is you draw an arrow and you put it just that way. It doesn't have to go all the way down. It could come to here and you could do it there as well. But this is called a ray. It has an endpoint at $5 and then it continues on to more than $5. $5 or more. At least $5. And that's it. That's all you have to do for those. Let's try it with Tess. Tess, let's use T for Tess, has at most, again a key phrase there, at most. At most means that she can't have more than $5, but she could have $5. That's the most that she could have. So that means that Tess has less than or equal to $5. So let's make that a number line again. 1, 2, 3, 4, and 5. Okay, so put a dot at 5 because she could have $5, but she can't have more than that, so she has somewhere in this region, at most $5, which is Tess has less than or equal to $5. And that's all it is. It's pretty simple stuff. Let's try one where we have two inequalities in the same problem. Rita has been mowing lawns to save money for a concert. Rita will need to work at least 6 hours to save enough money. Okay, so she has to work at least 6 hours. But she must work less than 16 hours this week. So she can't work more than 16 hours, but she has to work at least 6 hours. So let's write two inequalities. Rita has to work at least, which is greater than or equal to 6 hours, but Rita can't work more than 16 hours. So if she can't work more than 16 hours, she has to work less than 16 hours. Notice the difference between these two. Well, obviously this is greater than and this is less than, but this little bar underneath here is important. Okay, we don't have one here, we have one here, and that's going to change the way that we put it on the number line. So let's try that. 6 down here and 16 all the way up here. Okay, let's graph Rita greater than equal to 6 hours first. Let's use red for this one. Okay, so she has to work at least 6 hours and probably more. Okay, Rita, let's use blue for this one, cannot work more than 16 hours. Notice on this one, I filled this little dot in. Okay, because I have to include 6 in that inequality because it can be equal to 6. So I'm including it by making a filled in circle. If you notice, there's no line here, so I am not going to include 16 in that. And the way I show that on a number line is I make an open circle. Notice the difference. Closed circle, open circle. And she has to work at least 6 hours, could work more, all the way up to 16 hours, but cannot work 16 hours. So we do not include that in our inequality, so we leave it open. This little line here, and if you look back at our notes, we have our little lines, our equal to line. Both of our dots were closed. Our dot is closed here because we have a line. Open dot because there is no equal to. And now this inequality says at least 6 hours, but not more than 16. Pretty simple, pretty straightforward. It's pretty good. This would be one inequality, so you don't have to make two different ones. You can just make it all the same color. The important part is that we make sure that the greater than or equal to dot is filled in. Forgive my drawings. And the less than dot is not filled in. Let's try some situations here. Our first one says that n is less than or equal to -5. Okay, so n is all numbers less than or equal to -5. So what numbers are less than -5? Is -4 less than -5? No, that's actually bigger than -5. So we can't have -4 included on our number line. So let's start with 1, 2, 3, 4, 5. Let's go 0 here. Okay, 1, 2, 3, 4, 5 up here. And then -5 is down here. Okay, so where do we want to put our dot? Well, let's put our dot on -5. And if you notice that it has the little line underneath there, so it is a closed dot on -5. And we said we want numbers that are less than or equal to -5. Okay, so we said -4 is not less than that. -4 is right here. Remember, -4 is closer to 0. This would be -3, -2, -1, 0, 1, 2, 3, 4, 5. So if -4 is greater than, which way am I going to draw my arrow? Am I going to draw it to the left, or am I going to draw it to the right? Well, we're going to take it and say less than. Well, if you look at our arrow here, it looks like it's pointing this way. And this is a little trick, but it only works if your variable is on this side, on the left side. So we're going to point our arrow this way. And if you look, our inequality symbol is pointing that way. And that's the way we're going to go. But again, it only works if your variable is on the left side. Okay, notice variable left side, variable not on the left side. So we'll get a little tricky down there. Let's try next one. R is greater than 2. Well, let's just put 2 on here somewhere. Let's put 2 right here. Okay, so that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, R is greater than 2. So we're going to put a closed or open circle. This is closed or open circle. That's right, it's an open circle because no line underneath. Okay, open circle, and it's greater than. So my number, what numbers are greater than 2? Is 3 greater than 2? Yes, it is. Is 4 greater than 2? Yep. Is 1 greater than 2? No, it's not. So we aren't going towards the 1, which is over here. We're going to go towards the 3 and the 4. Open circle, and our arrow is going this way. And we can check. Pick a number on the number line right here. What number is that? Well, that's the number 9. Is 9 greater than 2? Yes, it is. That 9 makes that inequality true. And remember, open circle too. Open circle because there is no equal to sign. Equal, line underneath our inequality, closed circle. All right, we got negative 24 is greater than x. All right, so let's put some numbers on here. Negative 24, let's put that there. 23, 22, 21. So this is negative 19. 25, 26, 27, 28, 29. Negative 29. Okay, well, we have a closed or open circle. No line, so that's an open circle. And let's pick some numbers. Okay, so let's put numbers in for x. Well, negative 19. We're either going to go towards negative 19 or towards negative 29. So is negative 19, is negative 24 greater than negative 19? Which one's further from 0? Is negative 24 further from 0 or is negative 19 further from 0? So which one's greater? This is further from 0, so that's actually less than negative 19. Negative 24 should be less than negative 19, right? So we can't go this way. This one does not work. So we're not going to put our arrow this way. We're going to actually go the other way towards negative 29. Negative 24 is greater than negative 29. Is that true? Yes, it is. And let's jump back into, remember how I talked about our little trick up on the top, the arrow, the way it's going. If you look, our arrow in our inequality is actually going the opposite direction of this, and that's because our variable is on the right side. I said in these problems, if your variable's on the left side, your arrow is going to go in the same direction. Well, it's flipped here. Okay, your variable's on the opposite side, so your arrow goes the opposite direction. Same thing. What you could do is rewrite it. Instead of 57 is less than or equal to x, just flip it around. X is greater than or equal to 57. All right. Well, let's put them on here. Let's put 57 here in the middle. 58, 59, 60, 1, 2. 56, 55, 54, 53, 52. And let's just plug numbers in. Which way are we going to go towards? 52 or 62? Let's put 62 in here. Is 62 greater than or equal to 57? Yes, it is. So let's put our dot here. We know our arrow is going to go this way towards 62 because that made it true. What kind of dot are we going to have? Is it going to be a closed dot or an open dot? That's right, it's going to be a closed dot because of that equal sign. We can check it. We can put it into the equation. 57 is greater than or equal to 57. Is that true? Is 57 greater than or equal to 57? Yeah, 57 equals 57, so that makes it true. Oh, we got two of them here now. 3 is less than x, which is greater than 11. Okay? 3 is less than x, which is greater than 11. Well, let's do two different ones. Let's write our variable first. X is, and I can read from the variable, x is greater than 3. And we also have x is greater than 11. Let's actually change that up because that's going to be pretty much the same subset. Let's change this one and replace this greater than symbol. Let's make that into a less than symbol instead. Okay? So let's erase this one. And let's change that to x is less than 11. That'll be a more interesting one to graph. So let's start at 3. Let's put 3 here. Okay, 4, 5, 6, 7, 8, 9, 10, 11 right here. Okay, open or closed dots, open or closed. Is there a line underneath? No line, so open dots on both of those. And then we just connect them, and that's it. Let's check. Let's pick a number in here. Well, 3, 4, 5, 6, 7, 8. Let's pick 8. Okay, let's plug it in. 8 is, let's erase that so it makes it a little bit more clear for you. 8 is greater than 3. Is that true? Yes, it is. Let's try this one. Put the same number in. Don't change your numbers up. I'm just going to use a different color. 8 is less than 11. Is that true? Yes, it is. Both of those situations are true, so that makes that 8 is a true solution. I can put it in right here too. Ooh, that was bad. 8. There you go. That's better. 3 is less than 8, which is less than 11. And that's it. That's graphing inequalities. If you have any questions on this, make sure you post in the comments or post on the website. Let me know. Look forward to hearing from all of you. Have a great day.